Good day, viewers. You are welcome to today's edition. Today, we'll be naming some alkanoid compounds. The other time, we studied the concepts and we were able to see the types. If you have watched that, you understand where we are now. But you have not, you can still refer to it and see the continuation. Today, we want to see examples of alkanols and how to name them. I have some on the board. Let's start with number one. If you are given a compound like this and you have to name it, what you will do, if you are an amateur, can break it down. And I'm trying to break it down so that everyone will carry it along. This carbon atom here is bearing this methyl group that we have in parentheses on it. Alright? There will be one CH3 here, another one here, another one here. That is why you see that we have this CH3 and we have 3 outside, showing that there are 3 methyl groups attached to this carbon atom. And this same carbon atom is the one bearing this hydroxy group. And I told you in the last video that any carbon atom bearing the hydroxy group is a member of Alkanol family. So to name this, what you do, we have rules to naming alkanes. That rule is applicable here. Just identify the longest continuous chain, and that will give you the principal name. So you can name from here. This can be carbon 1, carbon 2, carbon 3, or carbon 1, carbon 2, carbon 3. Wherever you name from, you see that the carbon atom bearing the hydroxy group is on carbon 2. So the longest continuous chain is 3 carbon atoms. And when you have 3 carbon atoms and they are all single bonds, that is a propane from the word propane. Okay? So now we have what? 1, 2, 3. On carbon 2, there's a methyl attachment. So we have 2 methyl, showing that there's methyl group attached on carbon 2. 2 methyl, and the hydroxy group is on carbon 2. Alright, so we can now say 2, identifying where the hydroxy group is. So these 2 identify where the attachment is, and these 2 identify where the hydroxy group is. So the name of this compound is 2-methyl-propan-2-ol. I want to believe that you got that. Alright, let's see another example. This is a carbon atom, a carbon atom, a carbon atom. This one, the hydroxy group in parentheses, shows that it's attached to this carbon atom. And this chloride group shows that it's attached to this carbon atom. So you can break it down too, to help your understanding. And when you can break it down, it will help you to name it accurately. You can see the hydroxy group attached to this carbon atom. And this is another one. This chlorine attached to that carbon atom. And when you have gotten this skeletal structure, it will really help you to naming it. On this note now, one of the rules in naming a case says you should start from the shortest to any attachment. And the shortest is from this side. So this will be my carbon 1, this will be my carbon 2, carbon 3, carbon 4, and carbon 5. So you notice that on carbon 2, there's a chlorine attached. On carbon 3, there's a hydroxy group attached. So how do I name this now? This will be 2-chloro. Alright? Then what is the continuous longest chain? 5. 2-chloropentan. That's the longest chain. Pentan. And on carbon 3, there's the hydroxy group. Pentan 3-ol. Very simple. Another person can name it 2-chloro 3-hydroxyl pentane. It's still the same thing. But because we are really dealing with the Alkanol family, it will be better we have the ol, which is 2-chloro, you put comma, pentan 3-ol. I want to believe that you got that. Now let's see the third one. This is example 3. The same thing, you break it down. The carbon atom bearing this, carbon atom bearing this. Then this one shows that this CH2 occurs 3 times. So you are going to expand it. It occurs 3 times. There's one hydrogen here, there's one hydrogen here, there's one here, there's one here, there's one here. Then this one shows that there's an attachment of CH3 here, there's an attachment of another CH3 here, and there is hydroxy group. Because this CH3 having 2 atoms shows that the CH3 is attached here is 2. And of course, what we have here now, this will give me 1, 2, 3, 4, 5, 6. So the longest continuous chain is 6. And on carbon 2, there is hydroxyl group. So this will be, and on this same carbon 2, there is a methyl attachment. So the name of this compound will be 2-methyl. And the longest chain is what? 6. That will be hexane 2-or, to show that the hydroxyl group is on carbon 2. Very simple. Alright, let's see this one. Now, looking at this, there are 2 functional groups here. This is functional group COOH. If you have studied your functional group, you can see that anything COOH is an alkanoic family. We call alkanoic acid. So to break this down, you can have this, then your CH, your OH here, then this one, you have this, and you have OH. So how is the name of this compound? You must put the oic family. So this is, someone can call it 2-hydroxypropanoic acid, or you can say 2, I think that would be better for you to have it now because of the principal functional group here. So 2-hydroxypropanoic acid. Having 2 functional groups, the hydroxyl group and this one. But this one gives you the principal name. So that's the name of that compound.